I was very lucky that I could join the field of photonic integration in a very early stage. And I could witness its development into a technology which a great potential for our society. From my experience in radar technology, where I had worked with phased array radars, I thought it must also be possible in optical technology. Well, I got the idea during a sailing vacation, and when I got the idea, I started elaborating it, and well, it took me quite some time. So my wife remembers it still, but not in a positive way. What we published is that in an optical chip you can get coherent interference, that you can do focusing just like you do it in radar technology. In the beginning we didn't realize it, but later on it appeared to be groundbreaking. As you all know, in 1995, 1996, things changed a lot. Coherent communication appeared to be too difficult, and we moved massively to WDM, and at that moment the arrayed waveguide grating, the wavelength demultiplexer, was a key component in that technology. In the second stage of the development, we focused on integrating more and more components on a single chip. We developed the idea of standardizing the technology in such a way that many users could use the same technology for their application, and we call it generic foundry technology. It was a change, a kind of paradigm shift, so no longer optimizing the layer structure, but optimizing the circuit, so shift thinking from a component level to a circuit level. And now by sharing it, you got for a much lower amount, you get sufficient chips to optimize your design. In the early stages, it's much cheaper, and that makes it also, the threshold for starting with the technology is much lower also for small companies. So since 2005 we have been concentrating on this foundry model, and we did it together with other companies, and in the JePPIX platform we have been working together to develop the whole infrastructure for designing all kinds of chips for different applications in one single standardized technology. But a very important step for the future is the integration with electronics, and we're working on that by developing a technology, we call it IMOS, indium phosphide membrane on silicon, in which we integrate all photonic functionality that we have now in the generic process. Very thin membrane which we fabricate on top of a silicon wafer. And this silicon wafer can also contain electronics, so in this way we can integrate photonic functionality and electronic functionality in the same wafer. So I'm very happy that now more and more commercial companies are using this technology. It's a very nice conclusion of my career that we have brought it so far, that it has become sustainable. I'm very grateful to receive this prestigious award, and I would like to use the opportunity to thank my colleagues from the Photonic Integrated Circuits group who did most of the work for which I receive this award now, and without them it would have been impossible. And I would also like to thank the colleagues from the JePPIX platform whom we have collaborated in the past, and all the colleagues with which we worked in other projects and who helped making the foundry approach to a success. Thank you.